special values of theta such that tan of theta is equal to 1. And then let's think about what the value of arctan of 1 is actually equal to. So this is a bit confusing because of the fact that the arctan function is not a true inverse, it's only a partial inverse, remember, because we're restricting the domain of tan. But let's draw a unit circle so we can wrap our heads around the first part of the question. So I've got my unit circle here. And what's the deal? Well, it's a unit circle, standard stuff. And what does tan of theta mean? Well, tan of theta gives some position on the unit circle. And you've got this blue line coming out from the origin. And remember, tangent is equal to the slope of this line. Right, after carefully interpreting it properly. So we're looking for positions where the slope is 1. Well, there are two locations. There. So apologies. There. Or on the other side down here. So these positions are the two positions where you could be equal to 1. Now, special value that we know is pi over 4. So pi over 4 gives this. Pi over 4 gives this. And if we think about it, every other position on the unit circle which has this slope 1 is either at that position or the other side. That's always going to be half revolutions from this position with pi over 4. So what we can see is the following. Tan of theta is equal to 1 if and only if theta is equal to pi over 4 plus, let's say, k pi. Where very important, k is an integer. It represents a certain number of half revolutions. Kind of something we've seen many times now. So now, what's arctan of 1? Well, what you've got to understand is the restriction of arctan is between minus pi over 2 and pi over 2, not inclusive of the endpoints. So that means we're looking for positions around here. Right, this is the minus pi over 2 to pi over 2 part. And we've got one. Pi over 4 is exactly the right thing. So in this case, what do we conclude? So tan, so let me just write this down properly. So first of all, pi over 4 is between pi over 2 and minus pi over 2, so it's in the appropriate restriction, and tan of pi over 4 is equal to 1. This guarantees the arctan of 1 is pi over 4. It reverses it. Now, a mistake I see many times is people not writing this, but writing this instead, right? That is wrong. For the following reason, arctan is a function. There's one output to a given input, and this would have infinitely many outputs. So there's only one output, and by convention, it's the one that's between minus pi over 2 and pi over 2, right? Because that's the restriction that you're using to get the arctan function. So this is not correct. It wouldn't even be a function. It's just pi over 4.